Those of you who joined on Friday may notice that this lecture sounds a little bit different. It's going to cover the same information as we did live, but I had to come back and do an actual recording for those of your classmates who could not make Friday's lecture. So, okay. So just as a reminder, there's going to be no formal now you try it this week. And that is because Lab 2 is going to be focusing on what the Now You Try It would, and that's going to be significant figures. And unit conversions. There are a bunch of videos and then some readings. The only piece that you have to get done out of Lab 2 is this Lab 2 questions assignment. And that's due on the 14th. Lab 2 is completely online. I highly, highly, highly recommend that you take a look at that before you come to physical lab, where you will be doing Lab 3, which will be focused upon measurements in the chemical laboratory. And with this, there really isn't a lot of reading because it's built in with Lab 2. Before you get to lab, you need to do the pre-lab questions. So pre-lab questions for Lab 3 are due the Sunday. Oops, let's try that again. Sunday before your lab. Okay. Alrighty. So every measurement and calculated result based on measurements has some kind of uncertainty. Squeeze it in there. significant figures affectionately called SF are all the digits known with certainty and the estimated. What we are seeking to do is wanting to make sure that whatever value we are recording or we are reporting, we want to be able to determine how many significant figures are in that value. So determine the number of significant figures in a value as well as recognize the place of estimation. So where did that estimate occur? So those two pieces. Okay, so there's really 3 rules. And these 3 rules are a little bit different than what the reading material has. In the end, the reading material, the videos, and I are saying the same thing. This is just a different way of being able to determine the number of significant figures. So the first piece is actually pretty easy, and that is all non-zeros are significant. If I have a number like 321 or a number like 0.2946. Oh, try that again. 416 with 321. There are 3 sig figs. Okay, they're just 3 digits there. The 3, the 2, the 1. 0.29416. There are 5 digits. Okay. So rule number 2. The next two rules deal entirely with how we handle zeros. And so rule 2 is that no expressly given decimal point is written. In other words, there is only the implied decimal point. So only the implied decimal point is present. There we go. Not really sure the best way to put this down. By implied decimal point, we always put one in. If I wrote down a number, 321, and asked you, where is the ones spot? What's the ones place? It wouldn't take but a moment for you to look at me and go, why are you asking me something that's simple? Of course, this one that you just scribbled under, that's the ones place. Well, why? Well, because there is next door to it a decimal place gets put in just with our mind. Think back to lecture this week when we were doing this, how many atoms of each kind were in a compound, like H2O. And we said that there were 2 H's. Oh yeah, and there's just one oxygen. There you go. And I said how I know that is because just on the bare fact that I wrote down something, wrote down the O in the formula, means that there is a 1. It's implied. So in this case, we don't have a decimal place that's actually given to us. And this is a problem. let's consider the value 1020, and then we'll consider 42,300. The problem here is I do not know how well the particular measurement was made. So this value 1020, I know for sure it has at least 3 significant figures. How do I know? It has 3 non-zeros. But it could be 4. And I don't know how well that measurement was made. For this 42,300, I could have 3. I know for sure it has at least 3 because all non-zeros are significant. Or it could be 4, or it could be 5. And that's incredibly ugly. How did I come up with the 3? And then how do I communicate if I want to actually say, no, I've got, for example, in this 42,300 number, no, I've actually got 5 significant figures. They're all significant. This last 0 was my guess. What we're going to do is look at the value from right to left. So if I could draw a little eye here. There's my eye, my eyeball. Okay, I'm going to be examining the value, quote unquote, backwards. The first non-zero is considered the first significant figure. All other digits to the left. Whoa, that was fun. Sorry about that. Are also significant. We come back to this 1020 value. Again, I'm looking at it backwards. Hit my first non-zero, that would be the 2, and then the 0 and the 1. That's where I get the for sure 3 significant figures. This 42,300, it's the same idea. Take my eyeball, look at it backwards, hit my first non-zero, and then everything that comes before it is also considered significant. So there, again, my three significant figures. Okay, so case one, all the non-zeros are significant. Case two, no expressly given decimal point, so it's only implied. We know it's there. I just didn't write it down. The third rule, oops, there we go, or the third case is when we have an expressly given decimal point. Now this is, I'm going to write this value down and probably agree with me. This is not normally how you would see a number written down. 621 dot. Kind of weird. I realize that. 0.0153. And skip a couple lines here. How about 401.060? And then last but not least, is going to be this value 7200, again, decimal point. Okay, so let me run through these. This top one has three significant figures. That one is not too bad. That's all non-zeros. So that's easy. Okay. 0.00153 also has three significant figures. The zeros out front, those are just placeholders. $401,060 has six significant figures. In other words, this last zero here counts. All of them count. And then this value 7,200 with the decimal point, why that actually has four significant figures. Okay, awesome. Kinda. Here we go. We're going to have you look at the value from left to right. In other words, I got my eyeball on you, and I'm going to be looking at that value, what we would consider normal. The first non-zero is your first significant figure. So that would be the second piece. And then our third piece, all other digits to the right are also significant. So let's go back up here. And let's start looking at our little eyeball. I'm going to go back to my red eyeballs here. So I'm going to be looking from left to right. My first non-zero, it's a 6. And so it's the 6. And then everything that comes after that, further to the right, also significant. So that's where I get the 3. 0.0153. I'm going to hit my first non-zero, and then everything that comes after that to the right, also significant. My 400.060, same idea. Come across my first non-zero, that's the 4. Then everything else further to the right, also significant. 7,200. 7 is the first non-zero, and then everything that comes after it. By having the decimal point present, gives credence to this idea, okay, that spot, the ones spot, or, well, in particular with the ones spot for the 7,200, that is significant. What it's telling me is this is the estimated. If we go back to the previous ones, where I said it could be 3, or it could be 4, or it could be 5, the problem is I don't know Was the 3 the guess? Was the 10's spot the guess? Or was the 1's spot the guess? I don't know. I'm going to do a little bit of a CYA, cover your assets, and I'm going to assume that whoever made those measurements was using the most uncertain piece of equipment, the least precise piece of equipment they could. And so their uncertain place was the hundreds spot. By recording with that decimal point, that 7,200 dot, we're communicating that this last zero is indeed significant. So once again, the significant figure furthest to the right. Is our estimated. So again, that idea of 41,000 versus 41,000 dot. I know these first two. I know for sure. I know those are significant. The problem being, again, I don't know. Are the trailing zeros significant? Whereas the 41,000 with the decimal point, I know, boom, 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 all digits are significant. And let me grab my highlighter up here. The highlighted place is the estimated. So that is my estimated. Whether or not the zeros are significant, I don't know. It's going to depend upon how the measurement was made. So we're going to make the assumption that only the non-zeros count until we're given other information. Okay. So calculations and significant figures. 1. Really, we have just two modes here that we need to worry about. We have addition and we have subtraction. And how this go, addition and subtraction depend upon the degree of uncertainty, or where is that estimated digit. So the uncertainty of a result is given by the largest uncertainty in the calculation. This is best shown by doing some examples. So I'm going to do one addition and one subtraction. All right, so let's see, I'm going to take 462.0. So 462.0. And to that, I am going to add 321.55. All right, so both of them have decimal places. That means I'm going to be, right, looking from left to right. And my 4, my 6, my 2, and my 0. Because as soon as I hit a non-zero, I start significant. Boom, 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 boom. The significant figure furthest to the right is the estimate. That means for the number 462.0, I can record my estimation, my uncertainty, as it being plus or minus 0.1. The only reason why I put it as 0.1 is because I'm actually looking at the place. So it's 1 decimal place over. 321.55, same thing. First non-zero, everything further to the right, also significant. The value furthest to the right, the digit furthest to the right, that last significant figure, that's where that guess occurs. So here, that's plus or minus. Let me use a different color here. Yeah, let's go with the green. So this is plus or minus 0.01. Back. The question is, which one is bigger? This is larger. So my answer, my calculated result, must be rounded to the closest 0.1. So that's going to tell me how many decimal point places I'm going to keep. I'm going to do my calculator deal, and I'm going to have 783.55. And then I'm just going to remind myself that actually both of these are uncertain. I'm just going to carry the yellow mark down. I need to round it to the closest 0.1. So this is my little, hey, I'm rounding. And so that means it's 783 point. Well, this is the place I'm going to keep. Look next door, it's a 5. So I'm going to round this up to a 6. Same type of argument here with subtraction. So for subtraction, let's have 40.14630. And I'm going to subtract 1.29. And once again, I'm going to go ahead and look at how many sig figs and then where does the guess occur. So let's see. Oh, both of these have decimal places. All right. 1, 2, 3, 4, 5, 6, 7. The one that is furthest to the right, that is my guess. Same thing with the 1.29 on the 2, the 9. That means that my 9 is the guess. When you add or when you subtract, what did we learn when we were first going through addition and subtraction? What would we include under here? My teacher always made me write down their zeros just to make everything line up. Well, I don't know if that, I mean, that 9, it could be an 8. It could be, make it up to a 0.30. I don't know. I can't be any more sure after. So all of those would be estimations. I really only care about the fact that the 9 is the estimation. So this first one, it would be plus or minus 0.00001. And then down below, it would be plus or minus 0.01. This is bigger. So more uncertain. Round answer. To 0.01. Again, I'm just looking at that as where is the place that I'm going to be, the last place I'm going to be keeping. Alrighty, divey. So do the subtraction. We get 38.8563. Now, your calculator has this wonderful habit of leaving off zeros at the ends of numbers, particularly when they come after decimal points. All right. So any of these yellow uncertain tags, I'm just going to follow down. And I get to keep one of them. Place I'm going to be keeping is that place, the 0.01 place. So now I'm going to round it. And next to the 5 is a 630. It's more than halfway. So I end up with 38.86 as my final answer. That's addition subtraction. All right, so here we go. The second piece. So that's multiplication and division. Personally, I think this is much easier, much easier than, yeah, than doing addition and subtraction. Okay, so here's how it goes. The number of significant figures in a result is determined by the fewest significant figures in that calculation. Okay, so let's do an example of a multiplication. Let's do 16.01 and we'll do 210. Again, we'll go for a good old multiplication. 16.01, expressly given decimal place. So I'm going to be looking at it left to right. 1, 2, 3, 4. So here I have 4 significant figures. The 210 has an implied decimal point. Since it's an implied decimal point, I'm going to be looking at it backwards. I'm going to come across from right to left until I hit non-zero. And then everything further to the left, also significant. So here I have 2 sig figs. This means I will be rounding my final answer to 2 significant figures. So I'm going to do my calculation here, and it is 3,361.2. Oh, yeah, we'll do it this way. So let me put a box here and show you a common mistake that I have noticed in other students. Taking this 3,361.2 and rounding it to 2 significant figures, and I get the answer of 34. Yes, it does have 2 sig figs, but it is of it's a completely different number. And that's $3,361.20. You're owed $3,362. Oops, I can't. Sorry about that. $3,361.20. That's how much money you're owed. and somebody walks up and says, okay, debt's paid, and hands you $34. I don't know about you, but that debt's not paid. How can I express this number okay? So how can I round that number so it has only two significant figures? One way is just to toss zeros in. So that would be 3361.2. Okay, I'm going to round that to 3400, but don't put in that decimal point. You put in the decimal point, it changes the meaning of that ones spot. Or put it into scientific notation. So this is, let's see, 1, 2, actually, let me do this. So 3361.2. Okay, let's see, 1, 2, 3. Well, that is the same as 3.3612 times 10 to the third power. That 10 to the third power was just me bouncing the decimal place over. I'm just bouncing the decimal place over. I'm only going to be worried about this part when it comes to rounding. So now let's round that 3.3612 number so it's got two sig figs. That's not so bad. That's just 3, maybe. That's 3.4 times 10 to the third power. Okay, division example is going to be exactly the same general idea. 0.0150 over 5.8, which, just to give you a heads up, instead of seeing it as a fraction, one over the other, you may notice it instead as a slash. It means the same thing. Okay, so let's go through this. Both of them have decimal places. Both of them are going to let me go from left to right. So 0.0150. That's 3 sig figs. 5.8 is 2 sig figs. This means that 2 sig figs in that answer. So I do the calculation. The calculator spits out 0.002586207. Okay, I get to keep, again, 2 sig figs in my final answer. There's one. There's two. I'm going to be cutting off everything that follows. Oh, 0.0026. You can put this in scientific notation as well. It would be, let's see, I'm going to bounce it the other way. 1, 2, 3. So that would be 10 to the negative third. And then I would have out here 2.58627 times 10 to the negative third. Once again, two significant figures, 1 and 2. I'm still going to truncate here. After the 5 comes 862 blah, 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 more than halfway. Round it. 2.6 times 10 to the negative third power. I'm fine either way. And unless I specify one over the other, you can do it either way. The last piece is unit conversions. There are going to be some unit conversions that it will just make your life easier if you know, but don't go memorizing a bunch of these. Some are so common. You should just know them. Do not go memorize. Conversion factors. Not worth it. On your exams, you will get a book, well, not a book, a booklet of conversion factors, a periodic table, formulas, all that kind of stuff. Because I will be honest, I'm more interested in how you solve a question rather than just giving me the answer.